Thank you. Thank you, Julianne. Thank you so much. Hi, everyone. My name is Aida Issayeva, and today I'm going to be talking about simple recipes that will help you improve Android build times based on our experience here at Toast. And then what I usually do before the talk, I usually do that quick selfie. So if everybody can just smile, I'll try to do as much as possible. Like, hey, cheese. Hey. Okay. Awesome. Cool. Thank you so much. The lighting is really good here, by the way, from the stage. All right. Let's move on. Okay. So a little bit about me. I'm a staff software engineer and tech lead for POS productivity team at Toast. And today we're going to be talking a little bit about Toast, a little bit about our point of sale app. We're going to talk about growth pains that we have experienced. And then we're going to talk about quick wins and then all like low-hanging fruits that you can address within your build system, whether it's hardware, Gradle Properties, dependencies, updating CI scripts, looking at the settings in your CI container, and so on. So, Toast. Toast is a restaurant point of sale and management system that helps restaurants improve operations, increase sales and create better guest experience. It was founded back in 2012, and in early 2015, we had about 1,000 customers, 1,000 restaurants, right? Fast forward to 2023, we now serve about 100,000 restaurants across the US. And our point of sale app is running on over 500,000 devices. So our point of sale app is Android project with over 2 million lines of code, over 300 modules, Gradle modules we're talking about, and we have over 140 contributors to our code base, and we get average of 150 remote PR builds a day. Our POS app's build tooling state hasn't changed much since the early 2015s and 2013s. We use Gradle as our build system. We use Git as our version control, GitHub to store our code and manage our code, and Jenkins is our CI server. So as number of customers grew, so demand for new features has grown a lot, which meant company grew a lot, and the number of contributors has grown a lot. If in the beginning we had less than 10 contributors, now we have over 140 contributors within an 8-year period. We have more contributors, means we have more features to be built. And if in the beginning we had less than 50 features, now point of sale app is full-grown, gigantic product that contains multiple products with multiple features, with over 1,000 features at this point. And when you have a lot of features and you have a lot of contributors, what ends up happening is number of builds, remote builds, does increase. So we started with less than 2,000 builds a year. Now we're up to 26,000 builds a year only on PRs. So everything has increased in the past 8 years dramatically. And as a result of all of this growth, we also experienced that our build times has gone up as well too. Our average build times in the beginning of 2023, we started at 42 minutes, and by early 2023, we already have 75 minutes. That's the average build time for our PR builds. P90, it's even worse. So we went up to 77 in 2023. So, which meant our build times went up 44% just within a 1 year span period. So, why care about this problem? Why increased build times are important and we need to be addressing? First of all, when builds are taking longer, right? Fewer builds are being built. More builds are waiting in line, right? Which means more developers are waiting. If they decide to move on to the next task, then when they get the response from the other task, what they end up getting is they end up getting distracted. So their flow and focus gets distracted a lot. Hence, their developer experience goes down, which also means more product teams are waiting to get their features in. Release cycle keeps getting longer and longer. Customers are not happy, right? They end up not happy because their problems are not being addressed. They get very angry, and PS score goes down. And then essentially, business is suffering a lot as well too. So business is going down along the way. Hence, addressing the build issues are important. So in second half of 2023, we embarked on a journey of reducing build times in our POS builds. The project, as you see based on the graphs, was successful. We were able to bring down build times from average of 68 minutes comparing to early 2023 to 27 minutes in first quarter of 2024. So we're looking at 61% improvement in build times. And how we did it? By identifying and fixing low-hanging fruits and chasing those quick wins. And today I will share some of the tweaks we did in our systems that helped us gain these results. Someone wise or not so wise said on the internet, you cannot fix what you cannot see. Or maybe some kind of philosopher said back in the days, or like from some other book. And it's true. It's especially when it comes to debugging builds, it's really difficult to identify what caused the issue, like what was happening behind the scenes. And we end up introducing Gradle Enterprise, now it's called the Velocity, to our tooling system to help us diagnose and debug build details and see where were the bottlenecks along the way in our build. So let's start with the low-hanging fruits. First and foremost is the hardware. So imagine running your existing current code on MacBook Pro 12, right? Versus running the same code on your 2023 MacBook Pro Apple chip. Obviously, the same code will definitely perform better on your latest hardware. And so when you run code on old devices, you end up having longer build times. And the solution for that is throwing more computing power into the build times. Upgrading machines is a viable solution. So what it means, whether it's updating your new laptops or migrating to new controllers and new agents within your CI server, very viable. However, this quick win comes with a very high price tag, right? And especially as a company grows, you do need to be more careful and find that balance between the new devices, more CPU, more RAM, versus the cost, right? Especially as company grows, more contributors and developers are in the company, you end up evaluating those costs and making sure you're addressing them along the way. So it could be an opportunity to revisit the device renewal policy that you have at your company, or it could be opportunity to perhaps create one, right? Because of its cost, this low-hanging fruit is not really scalable, but it's still an option, right? Especially if you're a startup who got just a new series of A and B and you have money, why not buy new laptops? So that's the quick and easy win, but not so cheap. The next one, when it comes to improving build times, the next low-hanging fruit is updating your Gradle Properties. So Gradle Properties is a file that sits on the root of your Android project, and it's called Gradle.properties. That contains a list of all of the properties that you can modify that can be applied into your Gradle build system. Quick call out, you want to make sure between the property itself and the values to that property, you don't have any space, because if there is a space between that, Gradle will dismiss that value and will end up using the default one. And you might end up spending hours debugging the issue to just learn that the issue was that you added that space. So make sure you always keep this in mind when you're setting the values inside your properties. So within Gradle Properties, what kind of properties you can leverage to take and improve your build times? Number one, make sure you parallelize your tasks, Gradle tasks. You can do it by setting org.gradle parallel, name of the property, to be true. By default, this property is false, so you need to enable it manually first, so that all of the Gradle tasks can run in parallel instead of running sequentially. It will allow Gradle to build all of the sub-projects, all of the modules in parallel. The next one is enabling caching, build caching. So caching is a fundamental concept that implies that you're going to be reusing previously executed tasks. Gradle leverages concept of incremental builds, like clean build, and then you start with incremental builds, where you can use the build cache, where Gradle fingerprints each task's input and then stores each task's output and then applies that output to the other builds. And by turning the caching on, you can also, if you're using Gradle Enterprise, you can enable the remote caching, or remote caching also be enabled by using different host provider. Like AWS also has, you can set up your own caching with AWS as an alternative. The next one is making sure you manage your Gradle workers. You can do it by setting property workers.max to be whatever the number is. What the number is going to be based on available CPU cores. If you don't set the maximum workers, by default, they will end up taking all the available CPU cores. On your local machine, on your device, like especially the latest ones, like Apple chip ones, I think you have about 10 CPU cores. So Gradle will take up all of the 10, which is fine. But in some CIs, especially in Circle CI, the CI might report that they have 16 CPU cores. But in reality, the available cores are much, much less. So you need to keep this in mind and set the maximum workers. Otherwise, if you don't keep this in mind, in CIs, you might end up running into out-of-memory issue because there are no available cores. So you definitely want to set that maximum number of workers. Ideally, you want to set to be total available CPU cores divided by half. Like that's the math I came up with, and so far it's working well. For every company is different. The next one, now this is a big one. When application grows, we have over 2 million of, lines of code, right? It gets complex. It creates a lot of objects, which requires extensive data processing, which in return requires more memory to process. And that's why memory configuration is the most important setting you can apply to your builds and accelerate those builds. Within the memory configuration, by the way, memory configuration can be set under JVM args property. You need to focus on heap size, the heap, which is responsible for reducing time in garbage collection and maximizing throughput, which is transactions per second. You can set the heap size inside the JVM args, and the name of the value is going to be XM, and X stands for maximum heap. So, however, within the JVM memory, heap does not take all of the memory, right? Memory consists of heap, and it also consists of the ETA space, other native memory code, and so on. So that takes up the entire memory available, like JVM memory. Let's say it is 100%. What you need to keep in mind is that XMX, the maximum heap size, should be around 70-80%. And usually it should be size of the most hungriest Gradle task. Usually it's, if we're talking about the Android apps, it's going to be an app modules compilation or app modules minification task. If you have R8 enabled, there's also another element of minification tasks being very hungry. Because if you set your maximum heap size too low, your application will run out of memory. But if you set it too high, you end up wasting resources. That is not optimal, at least on the company level. Truthfully, identifying that maximum heap size, you can do it by just trials and errors. And it's different for every project. And I would say the best way to do it is just trying out and see how it turns out. Because sometimes it could be good, sometimes, it could be too high. Best start with slow, very low number, and just increment and see if you're going to hit the out-of-memory issues. Maximum heap size is responsible for throughput, right? Like transactions per second. You can also set initial heap size, which is setting initial heap size is important because you're letting a JVM know when it needs to dynamically resize the heap size or not. And then if you set the heap size to be, given the nature of Android projects, especially the production projects, Android projects are big and they require a lot of processing in general. So setting heap size, initial heap size to be high, I would say is okay. Like try to set 80% of your maximum heap size to be initial heap size, right? Like let's say if you have maximum heap size 10, then it makes sense to set the initial heap size to be 8 around that stuff. And then between 8, 10, it's going to be sitting well. Just because, you're going to be, when you reduce that initial heap size, like set the proper heap size, you're reducing the time JVM spends in garbage collection. So that's the one. And for initial heap size, it's going to be XMS, the name. Very easy and straightforward on that. Next one, continue conversation on managing memory. Most modern Android apps, they use Kotlin language to build features, right? Which means Kotlin daemon is running behind the scenes along with Gradle daemon. It usually starts when one of the Kotlin compile tasks starts to compile sources. If you don't specify the heap size for the Kotlin daemon, what ends up happening is Kotlin daemon ends up inheriting the values from your Gradle daemon. So like, let's say previously in our Gradle daemon we set to be 10 gigabyte. Kotlin daemon will inherit 10 gigabyte as their maximum heap size, and it will end up running all of that available memory. So in practice, however, like, you have to keep in mind that Kotlin daemon usually is much smaller, should be much smaller than the Gradle daemon. So, and now if we go back to the slide of the JVM memory, what the size of the JVM memory should be, if you know, like, let's say we have 10 gigabyte for the heap size of the Gradle daemon, we also left that 20% to be for native memory and meta space, which is going to be additional 2 gigabyte. It's going to be 12. And we also have 8 gigabyte for the Kotlin daemon. You have to be targeting making sure that your CI JVM memory will be at 20 gigabyte total available. So this is about Gradle properties. Next low-hanging fruit might not be so low-hanging, but it's important to mention is dependencies. And in dependencies, what we see oftentimes is that we have unused dependencies, right? Unused dependencies contribute a lot to time. Time and the size. When we talk about the time, we're talking about the dependency resolution because Gradle still need to resolve all of these dependencies in the build script, and hence it might end up downloading some of the artifacts if they're not cached locally. So it will spend time downloading, spend time configuring, resolving all of these dependencies just to, in the end, it's not going to be used at all by your project. And it also adds to the size of your jar, size of your class path, which can slow down your Java compiler. Besides unused dependencies, there's also another area of outdated dependencies that again adds up to the build time, right? So we're looking again at issues with dependency resolution because if dependencies are outdated, like it might complicate the resolution process. Gradle might spend more time looking for the new version, maybe the new version is sitting in a new repository, right? Gradle needs to resolve all these conflicts, pull that new version down, pull that old version, download it, and resolve along the way, right? So it adds up to the inefficient build process, adds up to the dependency resolution overall, and not to mention the fact that there could be deprecated features along the way in outdated dependencies that are not supported with a newer environment. Like let's say JDK is not supported by JDK 19 and so on, and you're sitting still on older version of AGP, right? So like all of these warnings and then additional compatibility settings will end up adding time in your configuration and complexity. And another reasons also include like compatibility issues, security patches, and the lack of support. Like let's say when you face issues with your outdated dependency and you file a bug ticket, the first thing first, bug ticket with my maintainers, what do they usually ask you to do? To upgrade dependencies, right? That's always the first step first. So you always gonna be facing issues with outdated dependencies. So what would be a quick solution for these issues, for both unused dependencies and outdated dependencies? The quick win around managing dependencies is to use plugins. To use plugins. There is this is a list of my favorite plugins that we use at our company. One of them is Dependency Analysis Gradle plugin, just identifies unused dependencies in your project, and then also identifies the transitive dependencies. And Dependabot, Renovate bot for you to automatically update your dependencies if you need to do. And it requires both of them to set up those plugins. It's less than a day of work, less of one developer you set up and you're good to go. You don't need to worry. However, just like with any quick wins, it always comes with catch-up moment. You need to be careful about migrating to the new version or updating to the new version because you also need to benchmark it first and make sure it doesn't contribute to performance and size regressions of your project. So that's where the catch-up moment is. All right, so after we finish looking into our project or build details, we started looking into our CI. What was happening in our CI, why our remote builds were still low, taking a long time. And what we learned, we found a lot of low-hanging fruits within our CI. For example, CI scripts. What we noticed is the CI stages, we're still executing one after another. For a small project, like let's say hackathon project, yeah, it might be suffice and it's good. But as project grows, like running, serially executing all of the CI stages, it ends up being very expensive, right? And becomes a big problem. We also noticed our Gradle tasks staggered across different stages. So let's say in one build, like let's say build stage, we're compiling our build, which means we're compiling all of the tasks in it. All of a sudden, in a different stage, we're recompiling again, but now this time around, we're recompiling the tests. So like why we're doing the two same work all over again. So that was interesting finding there. And the last low-hanging fruit was that we had so many different timeouts on different plugin responses. For example, we have SonarQube for our code coverage analysis, and there was a 60-minute timeout. Just sit there 60 minutes. Honestly, to give an example, all of the CI scripts have not been updated since early 2015 and 17 and so on. So hence, like, we're finally catching up and understanding what was happening and what needs to be paid attention to. So what we did, again, with addressing quick wins, parallelizing CI stages helped us a lot. We ended up combining Gradle tasks, helped us a lot there. And then we also started investigating and reducing timeouts across different plugins along the way. So those quick wins helped us to reduce our build times. After learning about the state of our CI scripts, we decided to look into our settings and configuration of our CI container. And there was another learning there. We learned so many settings were set back in 2015, 17, and they were still true, have not been updated since then. Our CI instance age dated back 2013. Agent counts was set still to be 10 as it was set back in the day, so have not been updated. Even though the number of builds have increased dramatically, the number of agent count was not updated. Agent instantiation, so we end up inheriting some of the agent instantiation from our backend development, which meant every time the build is complete, agent gets killed, and then the build starts, we have to instantiate the agent all over again. So that would add up to our build times. We also had a lot of build queue congestion. No wonder, because we don't have enough agents to begin with, right? So you can imagine we would have a lot of build queue. But to that build queue, what didn't help is that we would trigger builds for unnecessary events. For example, let's say in the PR, you change your PR description or PR title, it would kick off another build and put in the queue all over again. So like our build queue was congested dramatically. And how did we address these issues? The number one is we migrated to the newer instance of Jenkins. Hence, we were able to leverage a lot of predefined new settings from there. We also allocated higher number of agents. If we had 10, now we finally went to get 50 agents. Helped dramatically with our builds. Also, agent instantiation. So we end up having our own special agent pooling where we keep our agents warm and we don't kill them until the end of the day. So we can basically reuse them every time when a new build comes in. The same agent doesn't spend time on instantiating and rather starts running an actual project. That was the big win right there. Another thing that comes from our backend world is that in backend, you can build and release off of any commit concept, right? Doesn't really apply in the POS world, in the Android world specifically. So what we end up doing is we end up canceling ongoing builds if we know a new commit is being pushed. Helped us reduce the build queue a lot. And also, we end up revisiting all of our existing plugins and understand like if they trigger unnecessary builds. For example, the one with GitHub plugin specifically. And to recap, what we did is this low-hanging fruit we addressed. We enabled prioritization of the tasks. We enabled build cache, optimized memory config. We managed Gradle workers, upgraded hardware where it's applicable. I'm going to add that part. Optimized container settings. We fine-tuned some of the plugin events that our CI was getting, and we also improved CI scripts along the way. And what we did with these small, non-trivial changes, it helped us get build times down from 68 down to 27, which in return made our developers happy that time. all in all, while adding additional functionality into our CI, because we were also shifting left, so we were adding up additional stages, additional features into our builds along the way. But can we do it better? Of course we can. We can bring down build times even further. And the next step is to look at the code itself, and it's not something that can be called a quick win that will require this time around an actual big bet. And the big bet is modularization. As you saw, we have 2 million lines of code, but we have only 300 modules, or little over 300 modules. So we do need to invest in our true modularization to get the full benefits of Gradle build system. And that's something on our horizon. And that's it. That's my talk. Thank you so much, everyone.